Over the course of 4 months, I will be building and planning a whole electrical installation in one plane hangar and one car garage as my examination of becoming a certified electrician. Becoming an electrician has been a lifelong dream of mine. Ever since I can remember, I had the passion for electricity. So in 2020, as soon as I graduated from secondary school, I could finally get to the high school and start taking the 4.5-year long education to become an electrician. Today, 4.5 years have passed since I started my journey, but I won't spoil if I became an electrician or not. Because this video is about my process of taking the electrician exam from the beginning to the end. And there's the cat. Pretty cat. No. Jag kommer där. Hi. But first, some explaining of how the exam works. When you're closing up to the date when you're allowed to begin your exam, you have two choices. You could either take it in a booth or take it out in the field. There are both pros and cons with them, but I'm not going to go into much depth of how they're carried out. If you choose to take your exam in a booth, you'll get a task from your examination board, which usually is pretty simple. Build an electrical installation in made-up rooms. And what I mean with made-up rooms, since it is a booth, we usually split up the rooms in different sections. So one section could be the bathroom, the other one could be the kitchen, and the last part could be, let's say, the living room. Because different rooms have different regulations of how we build the installation. The great thing about taking the exam in a booth, you'll get it done in about a week, but the downside is you have to demolish the whole installation afterwards. And the biggest downside, at least in my opinion, you can't compare the work you do in a booth to what you'll encounter as an electrician. Because you're missing key elements like communication with the customer, regular working problems, and working together with other fields like the plumber, the carpenter and the painter. And you simply don't get that in a booth. If you choose to take it out in the field, the company you work for will look for a project, and if they find any, they'll reach out to the customer and ask if it is okay for the apprentice to take their exam on their project. If yes, you would have to reach out to the customer and figure out what they want and start planning the whole installation. The great thing about this way, it is exactly how it would be if you were an electrician, and you don't have to demolish your installation afterwards, so your exam will be standing for many years to come. But there's only one downside that I can think of, which is it could take multiple months doing it this way, depending on all of the fields that are working on a project. After all, you are building a whole house. When my time came to choose, I chose to take it out in the field. As you probably guessed. I still remember the day vividly when I got a phone call from my boss telling me that he had found a project that I could use as my exam. 5 minutes after that phone call, I began working on the project immediately and calling the customer to figure out what he wanted. After I knew what the customer wanted, I had to do a lot of paperwork. I had to calculate all the fuses to know if they would break at the end of each line. Also the voltage drop I was going to expect, and the resistance in the ground wire based on the length of the fuse, and a whole other calculations. And the reason for all of these calculations is because I had to make sure that the electrical installation won't catch on fire and also won't harm the customer. But what's in common for Norway, we have two types of grid systems, or basically three, but the last one isn't really being used anymore. The first one is the terra neutral system, which is the most common, where you have the neutral wire. And the second one, which is uncommon, is the isolated terra system. I won't go into much depth of how each of these systems work, but for my exam, I was building using the isolated terra system. Because I was building using the isolated terra system, I also had to calculate that in the case of a ground fault, the ground fault voltage couldn't go higher than 50 volts. At the end of the planning process, I had written 58 pages of construction drawings, wire diagrams, material needs, estimated time on the project, and the explanation of how the different grid systems works. It was a lot that went into the planning part, because the examination board had to accept the planning part before I could start building. So it had to be perfect and also safe. The day I sent them the planning part, I got my answer the same day. They loved it, and I got the green light to begin building. You make the planning part, and then the examination board validates the planning part, and then you can start building. But I've done it a little bit different, because I started building, done the planning part, and now I can continue building. And the reason for that is because the customer, which is the carpenter in this project, he wanted to start finishing the walls, and he can't finish the walls without an electrician. So I started a little bit earlier for the sake of time, to save that, so the carpenter can start doing something. So yeah, there's that. You can see behind me the wall have already started to form. Yeah, the rest of it isn't really done yet. I have a little bit of work on the walls that are still open. So yeah, this week I've been working consistently on this planning part to finish that. It became a really big planning part, like 58 pages of planning. The reason for that is you have to prove that all of the fuses and cables inside the fuse box can handle the amperage going out in the electrical installation mathematically. I've done that and everything seems to be fine. So yeah, the planning part consists of making drawings of the whole electrical installation and planning the fuses and the earth and stuff like that. Just plan the whole project down to the bone, down to the mathematics. So yeah, the whole week I've done that, and I just finished the planning part today. Hopefully I get an answer from the examination board that they have accepted my planning part, which means I can continue building. But yeah, in the meantime, while we wait, I guess we could install the outdoor lighting, because, well, what else to do while we wait? Okay, it's Monday and I have got my answer if my planning part has been accepted or not. And I'm happy to say that it has been accepted, which means we can actually complete the whole electrical installation until it's completely complete. There you go, all of the hidden cabling in the walls are pretty much done. And while we wait for the walls to finish, we can start installing the fuses in the fuse box and also install the outlets on the walls that are finished, like the wall behind me here. And in the meantime, I will also be working on laying the cable that will supply this whole building, so we can turn on the electricity on some of the outlets that are finished, which means we can get heat in here, which will make it much better to work in here, because yeah, it's getting cold. All of the walls are now done, which means we can finish up the electrical installation. All that's left is to install the outlets and some lights, and also make the fire detection system work properly. And after we've done that, we can take some measurements of the electrical installation to see if it works as it should, and make sure it doesn't catch on fire in the future. The electrical installation is now completely complete, which means we can finally move on with the tests. And there is basically 4 tests I have to perform to prove that this electrical installation is safe. So let's begin with the first one. So, So the first test is called continuity test, I think, if you translate it directly from Norwegian. But it basically means we're going to check the resistance from the outlets to the fuse box to see how much resistance there are in the earth wire. And if you measure too high of a resistance, that means there is an increased risk of getting a shock. There we go, all of the measurements have been taken and we are pretty much under 0.2 ohms on everyone. So, okay, let's move on to test number 2. Then we have isolation test, which basically is checking if the isolation between the live wires and earth wires have enough resistance, because there shouldn't be any connections between those 2 wires. And I'm hoping for a result that is as big as possible, but this is a test we can't do with the live electricity, so we have to take the power. So what I'm going to do with this instrument, I'm going to put 500 volts on each of these pins. So when I take one pin on earth and the other pin on the live wire, I will try to push 500 volts between those 2 wires. What's going to happen is hopefully nothing, because there shouldn't be any connections between them. So let's begin with the first live wire. We have 52 mega ohms, and the second one 53, then we have 54, and that's above the requirements, so this is fine. So should be fine. All right, the third test. This test is a little bit hard to explain. It's some sort of a short circuit testing, and what I'm basically going to do is to see how much amperage I could possibly get at the end of the fuse. The reason why we do this test is to see if the fuses will break in the case of a short circuit, and to know if they'll do that, we have to check if the short circuit amperage at the end of the fuse have enough amperage to actually break the fuse. And what's going to happen if we have too little amperage at the end of the line here? The fuse won't break and the whole circuit will just stay shorted. So the cable will get really hot and eventually catch fire. So this is really important to see if the fuse actually will break. And there is some factors to this. And in this case, with the fuses I have installed, I have to be above 150 amps in order for the fuses to break as they should. So if I measure under 150 ohms, 150 amps here, that means I have to switch the fuse with a other type of fuse that can take that low amperage. A little bit hard to explain, but it's basically just a way to check if the fuse will break in the case of a short circuit. So, and we measured 716 amps. But yeah, it's within the requirement. So I'm gonna take the rest. Then we have the last test, which basically is a test to see if the fuse will break if I get a ground fault. This instrument will simulate a ground fault, and we can see how much current that goes through and also how much time the fuse has used to break. There we go. It triggered at 24 milliamps and 38 milliseconds, and the regulation says we have to stay under 30 milliamps and also under 400 milliseconds, which we are. So let's take the rest. Alright, I've checked the whole electrical installation and everything is as it should. I didn't measure anything out of the ordinary, which means the only thing left now with the examination is basically the documentation for the installation, to just have the papers, and then we can get the judgment from the board to see if I become an electrician or not. I really hope I do, because I put a lot of work in this installation, and personally I think I've done a really good job. I'm confident to say that this installation is 100% safe and it shouldn't be to any danger for anyone. And the judgment date will be the 27th of January, which is about a little bit over a week, so a little bit of time to wait. So I'll see you in about a week. This is not mine. This is my friend Lucas's certification. Yeah, that guy. Because mine hasn't arrived in the mail yet. I can't do this. Alright, I'm officially a certified electrician and my childhood dream is complete. 3 months later, the building looks like this. It's a big difference from when it started back in October. The customer was so happy with the end result that he invited all of the people who worked on the project for dinner. And there, look, our seaplanes! The customer for this project is a microplane pilot himself and captain for a RC plane group, which my dad is part of. So it was destiny, you could say, that he made me buy my first RC plane myself. And yeah, filming and flying isn't exactly easy, but incredibly fun. If you made it this far in the video, I thank you so much for watching the process of taking my electrician exam and fulfilling my dream.